Okay, we're going to do 2.3, and we're taking this a little bit further. You noticed that when you graphed in 1.3 and Leanne was getting $10 from every person, regardless of how much she walked. When she walked 0 kilometers, she got $10 still. And that's where her 0 is. So her graph, her line did not start at 0, 0. It started at 0, 10. It started up on the y-axis. And Alana, who got a $5 donation added, right? She started with $5 and then added 50 cents per kilometer afterwards. That $5 she got at 0 kilometers. So her graph also, her line also started up the y-axis. It did not start at 0, 0. Gilberto was the only one who started at 0, 0. Okay, and the 2.3 is we're going to explore that a little bit more. In this case, the person running the fundraising decides to get everybody a shirt. Okay, so they go and get bids, which is, a life thing. I do that myself, and Mrs. Johnson did it for the academic challenge team, and anybody who does a sport, does things for coaches. The choir does shirts, the play does shirts, everybody does this, and they get bids, and we do it for the class trip too. So this is a very life experience kind of situation. So Mighty t-shirts, and you could see that here, Mighty t-shirts, okay, says, you have to pay $49 up front before you ever start. $49 to set up everything. I have to make a screen. I have to, get that stencil for the shirt. I have a setup fee. And so I'm going to say that no matter how many shirts you get, you're going to start with $49 before you start adding the cost of the actual each shirt. But I'm only going to charge you $1 a shirt. So it's only $1 of the shirt. And I want you to notice here, remember we said that there's an automatic 1 there. So that's $49 plus 1 N. So it's 1 shirt, it's $1. If N is 2, it's $2. Okay, notice we said $1 per shirt. I just want to clarify and make sure we're okay, because they're giving you the equations now. I want to make sure you understand what they're giving you. No shrink, which is here, okay, different deal. You say, no setup fee, no setup fee at all, don't worry about the screen, nothing. I'm just going to charge you a flat price for each shirt. So each shirt is going to cost $4.50. So the person who's getting the shirts is trying to figure out, what the heck is going on? Where do I get that better deal? And so A is all about figuring out where she is going to be able to get a better deal for the shirts for the fundraisers. And they're going to walk you through all the steps you need to take. It's very important that you graph this. You have to graph it. Listen to me. You have to graph it. It's necessary that you graph it. I need for you to see it again. Okay, so you're going to be graphing this and noticing how this looks. In the very beginning, on the previous page, which in the directions I've asked you to read, they are looking at 2 vocabulary words that I have used, but we're really going to, we have to make sure that we're very competent in understanding what they are. So the one here is the coefficient. The coefficient is the number you multiply or divide times the variable. It's really what it is it's the rate. It's the rate of increase. It's what it's increasing by. It's the rate of increase. Okay, that's how much it's going to go up by. It's a linear equation. As x goes up by 1, that coefficient, that number that you're multiplying times or multiplying or dividing by that variable, as x goes up by 1, y is going to go up by that amount. That's the rate. And when we did it in ratios and proportions, that unit rate was what we multiplied times the variable. That was the increase. Okay, that made it linear. That was that constant rate of increase. The y-intercept, which we have used less of, or I have, is where the line or the data intersects with the y-axis. Now think about this. Intercept. If I intercept a note you're passing to someone, I'm getting it. If a football player intercepts a pass, that means they bring that down. They get that ball. If I'm in soccer and I'm intercepting a pass, or basketball, I'm intercepting a pass, I'm getting that. That's where I have contact with that ball. Okay, so intercept is really a great word here. It's where where the y-axis intercepts the data. Okay, so it's the point where it's the point on the y-axis, and you're going to know what that is because it is the number that is added or subtracted in the equation. And you can tell if there's going to be a y-intercept because when x is 0, y is going to have a value because it's going to be whatever you're adding or subtracting. I want to look at B because I feel like in the past this has been confusing. They ask you in B, is this linear? Is this table linear? And I'm going to say yes, it's linear. It is, I'm telling you, I'm giving you the answer. Okay, here's what you need to do. You need to figure out how it's linear and what is the rate of increase. Notice here, I'm going up by 3, okay? And this is going up by 7.5 or $7.50. Okay, this is going up by 2. Okay, so it's not going up by 1 every time. It's not that easy. You have to figure it out. If it goes up by 2, this side goes up by 5. So you have to figure out if it goes, every time it goes up by 1, what is it going up by? Because that's the rate. I want you to notice here, okay, that this is the y-intercept. That is the y-intercept because it is the y value when x, or n in this case, is 0. Okay, so in this case, and this is a third place she goes to get a quote for shirts, they must be saying to her, even if you order no shirts, right, but before you add anything on, you're paying $35. You're paying $34. Okay, so that's the y-intercept because it's in the equation. It's what I'm going to be adding. Okay, I think those are enough hints. If you have questions, of course, I'll come and help. But I feel like that gives you a good start in working on 2.3. Good job.